Sadly, we have become aware of a sophisticated attack against our systems. The attackers gained access to all data associated with your account. Fortunately, financial information and credit card information has not been impacted. We take security seriously, and protecting your data remains our top priority. It's not an exact message, but a paraphrasing of a message we all received at one point in time or another. The flood started maybe 5 years ago. A lot of data breaches, a lot of security incidents, and a lot of things going wrong. And the victims usually are the users. The users who have their data stolen, their financial information, which is often the least of your concern, because that's usually the bank's problem and not your problem. But all of these things have a significant impact. And this talk can go in two directions. In one direction, we can make fun of these companies. We can laugh about how they screw up, about how ridiculously stupid they must be to have such vulnerabilities. I'm not going to do that. Because eventually, maybe already now, maybe in a few weeks, months, years, you'll realize that if I do that, I'm essentially a major asshole. Because in the end, it's not about these companies. In the end, it's about people behind these products. In the end, we're talking about something built by other developers who are trying their best to do the right thing, trying their best to build a secure application. And yes, things go wrong. Things go wrong everywhere. We drive cars on the road and things go wrong. It's the same in software development. And making fun of it, ridiculizing people and companies for getting it wrong is very unproductive. And that's why I want to focus on how we can improve things. I want to focus on some of the current issues we're facing today, and I'm going to talk about some of the things we, as a community, as developers, as managers, as business people, can actually do to improve the current state of security. The slide here has a couple of people, stock images, well, it's not stock images, but they're freely available images, but they represent some stereotypes I want to briefly talk about. The guy on the top right is a security bully. He's the guy screaming at developers for not understanding that security is important and they should get it right and whatnot. You don't need these people. They're not very productive. Seriously, I'm not going to talk about them even further. Better are security-curious developers. Developers interested in security. These are what, in larger companies, are people that grow to become security champions. These are absolutely valuable. Treasure these people if you have them in your company. If you are one of them, demand that they help you grow. Become better at security. You have the well-meaning developer on the bottom right. Well-meaning not as a derogatory term, but as someone who wants to do the best they can with the resources they have available. Someone who wants to build secure software with the knowledge they have and the time they have and everything else. On the top left, you have the intern. Again, it's a stereotype. It's actually from a real story from a customer of mine. They learned about a lot of security issues in one of my courses, and a few months later, they told me, like, yeah, after that course we had an intern, and that intern made the exact mistake we talked about. But because we knew of that mistake, we could easily stop it, well, detect it, stop it, and prevent it. Otherwise, we would have had a major vulnerability in our production applications. Again, these people don't want to write bad code. They just, well, in an intern case, they're maybe often overconfident that they know what they're doing, even though they're just getting started. Not maliciousness, just the way things are. And I want to focus on the last three groups of these people. How can we help to make it better? How can we help them to do a better job? And there's both process things and actual security technologies we can use there. One of the first and most important things to realize is there's too much to know. I'm a web security expert, and I say that with some reservation. There's a lot I don't know. There's a massive amount of stuff I don't know. It's normal. There's so much going on today that you simply cannot know everything. So the best thing you can do to improve security is use frameworks that offer secure by default settings. One of these examples I like to talk about a lot is Angular. Who here is using Angular as a web framework? All right. Who's using something else like React? All right, so sounds about right, half-half. I'm talking about Angular because Angular, in my opinion, is the most security-complete framework. The other ones have elements of it, but they don't go as far as Angular goes. But that's not the topic of this talk. What I want to talk about is how Angular helps you to build more secure applications. Instead of building a traditional web application where everything happens on the server and you ship something to the browser which shows a page, and then if you do something, it happens again, Angular runs on the client. Meaning you have an API where you can fetch some data, in this case reviews for a restaurant, and on the client side you have your template, your application, a skeleton where you plug in data, and all of a sudden you get a valuable application. I'm making this very short now, but you kind of get the idea. This is how you do data binding in Angular. You have these curly brackets, and you assign a variable to it, and Angular will substitute that variable for whatever contents it holds. This is how you can put a title in the page, or a review, or whatever. It's called my dirty data. It's not as dirty as you might think, but it's data that might contain untrusted input. This might result in a cross-site scripting vulnerability. However, in the Angular world, whenever you do this, Angular will guarantee that there will be no script execution coming from this data. It will be inserted into the page as text and text only. As a developer, you used to need to know a lot about cross-site scripting. Now you need to know Angular does this for me. I'm good. I don't need to learn about all the intricate details of the defenses. Awesome. If you've ever done this, you know that it's sometimes too protective. Sometimes you actually want little bits of HTML in the output in a web application. So in that case, Angular offers the option to bind to a property called inner HTML. This is not the DOM API level inner HTML, but this is an Angular-specific thing that proxies your request to the DOM APIs. Again, my dirty data is there. This will be data containing some HTML, might be an image there, might be some headers or whatever. But the good thing is, there will be no script execution. Regardless of what you give it, Angular will first sanitize this data before putting it into the page. By default. Again, no need for a developer to figure out how the hell do I sanitize? What library do I use? Where do I get it? How do I import it? No, it just happens out of the box. Awesome. Of course, you can bypass this mechanism. Sometimes you need to do something that this mechanism doesn't allow you to do, so there's a function for that as well, and it's called, or in Angular 1, it was called trust as HTML. And you see that my dirty data is red now because this is unsafe. If you feed it through this function, Angular will simply mark it as safe and will not touch it with its protection mechanisms, because you as a developer vouch that this data is safe, meaning you should only use this for static code snippets, never ever for untrusted input. Turns out, the name of the function was a bit unfortunate. Because trust as HTML, people kind of thought, oh yeah, this is a trustworthy function, it does something to make my data safe, while it does the exact opposite. Resulted in a lot of confusion, a lot of bad advice, Stack Overflow posts giving people security advice while it actually did the complete opposite and opened a security hole in your application. So they said, we're not going to call it trust as HTML. In Angular 2 or 7 or whatever, it's called bypass security trust HTML. Small cosmetic change. Just the functionality remains the same, it's just the name that changes. And the small cosmetic change is enough for most developers to have something triggered when they write this, like, hey, what does this bypass security thing mean? Maybe it's something I should at least look up, and you'll find the documentation saying like, oh wait, no, you cannot use this for user input, it's very, very dangerous. If you find a code snippet on Stack Overflow, 5 lines of code, and one of the lines is bypass security, and you don't think about the potential ramifications, if you're a developer, my apologies, but you need to find a different job. Development is probably not going to be your strong suit, or security development is not going to be it. But that's an illustration of how simple it can be to give developers a nudge towards security. Because a well-meaning developer, somebody who has limited time and resources but wants to do the best job possible, will be triggered by this and will be like, oh, wait a minute, I need to ask my colleague who knows more about this. And you have avoided potential vulnerabilities. And to show you why this is so important, I'm going to show you the other side. This is jQuery, another JavaScript library for building applications. And they have an append function. You can see that my dirty data is red, so it's probably not going to be a good story here. This append function is used to append stuff into the DOM. How do you know whether it's secure or not? Well, because it's red, of course, but in reality, how would you know? You would go to read the documentation. First of all, to figure out what the arguments are, and second of all, maybe you find some useful information there. I went there. This is the documentation for append. You can see here, it's a simple page. It explains how to use this function. No mention of security, no mention of anything else except the argument. So let's scroll a bit further down. Oh yeah, there's some more arguments, some code examples, very interesting. No security. Let's scroll down. More code examples, references to similar functions like prepend and before. And then on the fourth page, there's a section called additional notes. Oh, by the way, if you're still reading, which I can guarantee you almost no developer will be, because they know what they need to know. They know how to use the function, and that's about it. And then there's a section saying like, yeah, this is actually very, very insecure, and it will almost always result in cross-site scripting. All right. You might want to put this on top of the page in a red box saying like, watch out. This is dangerous if you use this with data where you don't know where it comes from. If you use this with user-provided data, you're creating a cross-site scripting vulnerability in your application. And again, I'm not blaming the jQuery developers. I'm just using this as an example to illustrate why these names actually matter. If this function would have been called insecure append, everybody would probably know, oh, I need to watch out here. That brings us to an interesting pattern. Because you could try to update jQuery, but getting that done is going to take you 5 to 10 years, maybe even longer, to have all instances of jQuery updated. So it's not very practical. But what you can do is you can write your own security library. You can, if you're using jQuery and you want to enforce better code hygiene, why not encapsulate jQuery or parts of jQuery in your own library? That way, you can hide this dangerous append function. And you can expose the append function as insecure append. And then, of course, you can also expose a secure append function where you do some default protections like sanitization. And this is a library that you will use in your application. And because of that, you have some more guarantees that you are using the right functions. And what's even better, if you follow this pattern, you can use linting rules when you build your code to find abuses of the raw jQuery append function. You can easily find them in the code. That's a very simple rule you have to implement. And boom, all of a sudden, nobody can use this append function without it being flagged by the linting tool. You actually break the build when somebody uses these functions directly. And at that moment, you have a lot more security guarantees in your code, just with some simple cosmetics. And that's a very important thing to realize. And this is something that people are starting to see as kind of a very good solution. And they're bringing this deeper into the web platform. So Trusted Types is one of these initiatives coming from Google. They've been using this internally for a long time, and they're pushing this into Chrome now. I think it's still available behind a flag, so you have to enable it explicitly. But in a couple of weeks or months, this will land in every version of Chrome. And it essentially applies the same mechanism to the DOM APIs. You can only put something into the page if it has been passed through a security function. So you absolutely can, the browser will enforce that you can only put safe data into the DOM, basically killing DOM-based cross-site scripting. I have no time to go into any detail, but there's a great video from a conference 2 months ago in Hawaii I strongly recommend to watch. It's by one of the creators, Christoph Godowitz, and he absolutely knows the ins and outs of these details. By the way, the slides are available on my Twitter feed, so you can easily grab them there after the talk as well, but take as many pictures as you want. If you want me to post, just let me know and I'll do whatever you want to. Brings me to the first important point here. Developers don't want to build insecure applications, but you need to help them, or they need some help getting there. And one of the things that really helps is secure by default frameworks. This is absolutely important because it reduces the need for knowledge. Explaining someone to handle cross-site scripting in PHP takes 3 to 4 hours maybe, while in Angular it takes like half an hour. Don't do this, everything else is covered. Awesome. Subtle security nudges. Name things what they are. If a function or a feature is insecure, call it insecure. It helps mistakes. It helps, or it adds implicit knowledge there. And encapsulating dangerous features also helps really well. All right, back to our people. There's one person we haven't talked about. The guy that looks a bit, well, let's call it overwhelmed in the bottom left corner. That's your open source developer. You're laughing with this, but this is not a joke. This is unfortunately a very hard reality. Today we build modern web applications and we use a lot of open source components. Angular is an open source component, although I believe that the Angular people are pretty happy because Google treats them pretty well. But a lot of NPM stuff, a lot of dependencies are built by people in their free time, and we often forget that it's people behind all of this software. More than 97% of a modern web application is third-party code. Code written by someone else that you include as a dependency. 97%, that's absurd. NPM is by far the biggest ecosystem. And there's a few others. We have this ecosystem for a long time. RubyGems has been around for ages, Maven as well. But NPM, the recent one, has overtaken everyone. You can see that Maven is trying to catch up, but I'm not sure whether it will actually ever get there. But this is insane. Over 1 million packages today. This data is already a few months old. It's from the SNCC report on open source security. That's a lot of code. I ran the numbers, especially for this presentation. I initiated a new Angular application using the CLI. ng, new, and your app name. Ask you some questions like, do you want routing? Yeah, sure, I want to build a real application, so yes, add routing. And I want to use SAS for style sheets, pretty default configurations. It runs npm install in the background, so it's going to take a while to get some results from that. But it takes 30 seconds to initialize the application, and after that, we have installed 1,169 packages. That sounds, yeah, sure. I see some skeptical faces like, is it really that much? Well, let's look at lines of code. CLOC is actually an npm tool, so I had to install an npm package to count the lines of code, but nonetheless, it calculated the lines of code of the dependency folder. Look at the bottom right. 2,336,228 lines of code in my application. 2 million. You know how much I have written in that application? 0. I just initialized a new Angular app, and all of a sudden we have 2 million lines of code that we already include as a dependency. Wow. And if you look back at this image, there's one thing that pops out. 1,030 contributors. And that's the lower bound, because I believe, I haven't looked it up, but I believe these are npm publishers. So behind every publish, there's a whole team building, or usually a team building that software. So you thought you were a single developer building an application, but actually you have 1,030 colleagues that nobody has to pay, by the way. And you can imagine in an ecosystem like this, there might be some problems as well. And we have some problems in the npm ecosystem. And this is one of the major challenges many applications face today. Here's an example from, I think, a year ago or half a year ago, November 2018. An npm library, 2 million installations, and somebody added a backdoor. What happened here? Well, it involves people. It's not this npm library that did something bad. No, it's a developer behind the library. And people gave the developer, they almost physically hurt him for this. It's insane. What happened is, Dominic Tarr built a library. He was building an application, he needed functionality, he thought, hey, maybe other people think this is interesting as well, and he built a library and he published it. And people thought it was interesting, and they started using it. And then he moved on to something else, and he didn't really care about that anymore. And all of a sudden he gets an email from someone else in the community saying like, hey man, I love what you've been doing. Do you mind if I help you maintain the library? I have some ideas, I want to improve certain things and update certain things. And he was like, yeah, I don't really use it anyway, so yeah, sure. And he gave them access to the repo. Sounds normal, somebody wanting to help. Of course, in this case, it was the attacker, and the attacker actually succeeded in injecting malware into the package and publishing an updated version, which got installed by everyone around, or a lot of people around the world. And you can see the GitHub emoji icons. I don't know what they mean, I don't use them, but you can imagine that the guy had to eat not a plate of crap, but a truckload of crap for this, while he was contributing a library to npm in his free time. It's people behind this. Other problems. How do you know which package you're installing? I made a small game out of it. Let's say you want to install the cross-env package. Which one do you choose? Who chooses the left one? The one without a dash. All right, the right one? A lot more. Let's see. Good. The majority was right. They got the real package. The other ones got malware. Oops. Actually, you don't even notice this because the cross-env, the red one, uses the green one as a dependency. So it actually does what it's supposed to do, plus something extra. Whoops. Another one. CoffeeScript. Who chooses the left one? Who chooses the right one? It's not always the same pattern, by the way. You both got screwed. Because it's CoffeeScript with 2 E's, not with 1 E. And sure, this is a very fun game, but in reality, this is not a joke. In reality, your software now got compromised. You now have a vulnerable applications because you forgot to type 1 single E. This is madness. And these things happen, there's plenty more examples, and it's called typo squatting. And it's been around for ages in every aspect of IT that we use. Domain names. People buy Google.com in the hope that you mistype Google and end up on their website. Sometimes it's malicious, sometimes it's advertisement, sometimes they want to sell you something, but it's the same attack vector, and now it exists in NPM packages, which you install in your application. So yeah, we have some problems here, and it gets worse. Here's an attack from last week. Anybody hear about Agama, the crypto wallet? It's a product. It's an open source product where you can keep your cryptocurrency in some wallet, and they have an Electron app to manage that. And the hacker, posing as a good guy, was like, hey, I love your application. What if we would add some native notifications? Wouldn't that be a cool feature? And the developers of the app were like, yeah, actually, that would be pretty cool. And the hacker was like, awesome, you know what? I'm going to create a pull request for you so you can integrate that into your code. And the maintainers were like, awesome, free code. Yes, please. So he did that. He built a package called Electron Notify Native. He published that on NPM, used that in the pull request, and it got integrated into the application. So far, we have seen nothing else than a normal pattern in the open source community. This is what makes our community so wonderful. People contributing, adding a pull request with some real useful information. Functionality, awesome. Of course, once this happened, the attacker was like, aha, now I'm going to update my Electron Notify Native package and add some malware. Whoops. This is happening in March. We're March 8, March 23. After 3 weeks later, the original app updated their dependencies, and they now have the malicious dependency included in their application. And this is where it actually gets interesting. This is not a sad story, it's a good story, because the NPM security team noticed what was happening. The malware he installed was leaking seeds to a public server and collecting them all, waiting for the big hit and run, like grab all the cryptocurrency and go away with it. Spend it all on God knows what. So the NPM team warns the company behind this product, and they investigated the problem, and they eventually decided, we're in trouble, and they used the vulnerability to steal the money from all of their users themselves. They took all the money and they put it in a safe location. And then they contacted all their users and they said, like, yeah, you know, we had this problem. We preemptively stole all your money, but you can reclaim it by going here and reinitializing your wallet with your original funds in our new application, which we already had, by the way, but it's more secure and so on. But this was a close call. Maybe a week later, all the money would have been gone, and this was about millions of dollar equivalent money. And the real scary part here is that this is a targeted attack. This was specifically targeted against this one product, and they succeeded in including a legitimate dependency which then becomes malicious. And that shows you how fragile this whole ecosystem is. And unfortunately, there's no very good solutions here. This is something we are stuck with, and we are actively figuring out how to do this better. Because it turns out that 78% of vulnerabilities in your dependencies occur in indirect dependencies. Not the ones listed in your package.json, no, the ones included by your dependencies that you include, somewhere down the line. And that's a very, very scary picture. And the best thing we have today to fix that is monitoring. We can monitor our dependencies. Services offer that. GitHub is the easiest one. If you're using GitHub, it's like going to security settings, I think, and you say, enable dependency graph, and off you go. And GitHub will email you like, hey, this week you have these dependencies with vulnerabilities. And if a new one comes out, they will email you immediately like, you need to update this. OWASP has a similar tool called Dependency Check. It's freely available. You can run this as an offline client, so you can run this in more corporate environments if you don't use GitHub. And there's commercial products as well. Snyk has a free version for small developer or small-time developers or open source developers, and of course they have an enterprise setup as well. The nice thing here is that they offer integration with pull requests, so they automatically create a pull request with updated versions, so you can run all of your tests on that branch and decide to integrate that update, yes or no. But monitoring your dependencies and securing your dependencies is absolutely crucial. Today, the best we can do is monitor known vulnerabilities and patch as soon as we can. You should have an urgent patch cycle in place. Like, who are you going to call if you need to update this immediately? If you get a warning, do you know who's responsible for that in your company? If not, you probably need to figure that out rather sooner than later. And we have similar problems in the JavaScript world. JavaScript has been around longer than NPM, and websites include JavaScript from all over the place. And things tend to go wrong. Ask Ticketmaster. Ticketmaster has suffered kind of a problem from the group called MageGuard. It's essentially a group of attackers all trying to do the same thing, and they want to steal credit card information from websites accepting credit cards. And they do that from JavaScript by compromising a JavaScript file somewhere. Here's what happened with Ticketmaster. Ticketmaster uses these third-party dependencies, services like Social Plus and Inventa and a dozen others to provide additional services for their website, like insights, analytics, marketing, God knows what. Attackers figured this out, and they compromised one of the providers, Social Plus, and installed credit card skimming malware on there. It got loaded in the Ticketmaster website. The malware was configured to look for specific pages with credit card information and siphon it off somewhere else. Why? Not because the hackers want to go Amazon shopping, but because credit cards are actually worth money on the black market. If you have 1,000 credit card information with associated personal information, that's worth real money. This worked really well. So the attackers were like, this is awesome, credit card information. What if we could grab some more? Maybe other places in Ticketmaster, other applications, because they have a lot of geographically different applications. So they compromised a second provider, Inventa. They installed credit card skimming malware, and they started grabbing more credit card information from Ticketmaster, like a golden goose, so to say. Ticketmaster eventually caught on to it in June 27. So that's about 6 months of credit card information being stolen. And they announced, like, yeah, we got breached, this was bad. Sorry, we lost about a couple of months of credit card information, and our bad. They either they didn't know or they downplayed the issue. But there's an analysis firm, I think they're based in the Netherlands, RiskIQ, and they actually did a more in-depth analysis because they keep a history of the internet. They can go back to these specific JavaScript files and they can see when they were last modified. And that's how they figured out that this actually was going on much longer than Ticketmaster thought. But this is a problem. You rely on this third party, they give you code, you include it, and it basically screws you over. So what can you do against this? Well, there's a few things you can do, but it's, again, not that simple. One of the easiest things you can do is you can use a mechanism called sub-resource integrity. And essentially what it allows you to do is if you load a file from a CDN in your browser, you're going to tell the CDN, I want this specific version of Angular. And the CDN is going to serve you a file. But if it's compromised, you would get Angular plus a little extra. With SRI, you include an integrity attribute in your script tag. You say, by the way, the SHA-384 hash of this file should be this very long string. And the browser will check that for you. The browser, when it receives the file and you have this integrity attribute, the browser looks at the contents of the file, calculates the SHA-384, and compares it to the one you have given the browser. And if they match, you know that the contents have not been changed since you added this to your application. And if they no longer match, you know that what you're getting is not Angular 1.7. We don't care what it is, we just don't want it. And the browser will check that and reject that file. This is a mechanism you can easily use. Used a lot on CDNs. If you copy files like Bootstrap and include them in your file, it actually includes the integrity attribute right there in the HTML you have to copy-paste. Awesome. You can do it for other files as well. There's an SRI hash generator website where you can easily paste in a link and it will generate the hash for you. And if you really hate yourself, you can use OpenSSL on the command line as well. Well, if you copy-paste it from the slide, it's not that bad, but figuring this out yourself is not going to be fun. This is SRI. This works really well for static files, files that do not change after they have been deployed. Files like Imbenta and Socia Plus were usually things that do change after a while, and you cannot use SRI that easily, because once the file changes and you have a checksum, it breaks the inclusion in your website. So either you have to convince your vendors to provide version libraries where you can use SRI, or you have to find other solutions. And that's where things get a bit tricky. Another thing you can do is you can think about your application not as one big blob, but as different trust zones. So here's an example of a restaurant review application, one of my training applications. It has some public content, the reviews. It has some private content, posting a review, your account settings, and it has an admin interface. As you can see here, everything runs under restograde.com. So this means if something goes wrong here, if something goes wrong on the left, let's say a malicious advertisement, that one can easily spread to the other parts of the application. There's no boundaries, there's no nothing. Everything is one big happy application. If you would have deployed this under different domains, the origins would be different as well. So now we have the public restograde.com. If you click on login, you go to users.restograde.com, and the admin can go to admin.restograde.com. And because these are different origins, the browser will actually isolate these things from each other. So if something goes wrong in one part of the application, it doesn't automatically spread to the others. It's going to be a lot harder to do this. And it might impact or limit the attack that's going on. And you have more control as well. Because now you can decide, hey, maybe I shouldn't include ads in the user part and the admin part, because that's kind of really sensitive. I'll only include that in the public part of the application. And you get isolation. But doing this requires knowledge on how to do this, effort on building out these systems, but in the end, I believe this is crucial for guaranteeing secure applications. Leverage this mechanism. By the way, this is not something new. This has been around for 20 years. We simply haven't evolved into using that as an effective mechanism within a single application. That brings me to the next topic. Who here does not know about the Equifax data breach? Seriously, it's okay to say you don't know about that. All right. Wow, more than I expected. Okay, let's tell the story. Equifax is a US company. In the US, you have credit scores to say how good your credit is, as in how likely it is for you to pay back a loan if you get one, something like that. So people are very obsessed with that because it means it essentially decides whether you can get a loan for a house or something like that. Equifax is one of these companies that keeps track of your credit scores. Very sensitive information. They build applications with the Apache Struts 2 framework. Whether that's a good choice or not, I'm going to leave that in the middle, but they do. So far, so good. Turns out that the Apache Struts framework had a vulnerability, remote code execution, meaning somebody could use it to execute remote code on the server that's running that. That's as bad as they get, vulnerability-wise. So the Apache, they got a silent report from that, they fixed it, they patched it, and then they send out an advisory saying like, yeah, we had this bad problem, patch it now. Whenever you release a vulnerability patch, the bad guys are going to look at it. They're going to look at, what did you patch? Oh, that's interesting, I can abuse that. So they go looking for servers that haven't been patched. And they came knocking at Equifax's door. And they got in. They started exploring the systems, and they started a wide-scale exfiltration or a full-scale exfiltration of the data. They got millions and millions of records. This was one of the baddest breaches of US and UK-based information. Equifax discovered the breach July 29. It started in March 10th. 6 months. They reported in September 7th, after an internal investigation, and after some Equifax people dumped some stock before the price dropped. This is not a joke. Some people actually got convicted for that. But the real scary part is the green and red here. March 7, the advisory is published. March 10, the first attack is launched against Equifax. 3 days, 72 hours. Who here, in all honesty, can say that if an advisory comes out, that they have patched all their systems within 3 days? Show of hands. 3 people. That's about 297 people that might be in the same situation as Equifax. This is absolutely insane how fast it goes. That's not the point I want to make here. Well, partially. But this portion is about something else. Here's another example from a few weeks ago again. First American Financial contains insurance information about a lot of Americans. And they got breached. It was a real sophisticated attack. So somebody figured out that in the URL you have this very long number, and if you subtract 1 from that number, you get a different document. And if you keep doing that, you can go all the way back to number 75, which is the oldest document in the system. Hundreds of millions of records through mathematics. I'm making fun of them now because honestly, this is a silly vulnerability, but it happened. And what surprises me the most here is that nobody detected this before the data leaked. Or it took 6 months in the Equifax case to detect that this is happening because they weren't monitoring enough. You need to monitor all your services. You need to monitor when something like this is happening. Whenever you see a peak in usage, it's probably not because you got 20,000 extra users. It's probably because something's seriously wrong. And this should trigger alerts. And even if you don't get the alerts, monitoring is so important for the post-mortem after something happens. Because if you find a vulnerability in your systems, how will you ever know if it has been exploited in the past? If you have SQL injection, like, oh crap, we had this really big SQL injection problem, we fixed it, so we're good. But how do you know? What if I have come in a year before and changed some data in the database? How would you ever know if you don't have monitoring and if you don't analyze these logs? So today, this is one of the most crucial aspects that's often neglected or useless. Brings me to the last stories. Facebook. My God, Facebook. They apparently stored hundreds of millions of passwords in plain text. This is typical media bullshit. The title is hardly correct. It's like flirting with the truth here. They didn't store the passwords in plain text. They had monitoring enabled. They did request logging. It's a good practice to do request logging. Of course, you should think when you enable request logging, where you get all the requests with all the data that's being sent to your application and you put it in a log somewhere for analysis, that some fields should probably not be logged, and that's a password field. I could have fallen victim to this as well. I have an application where I do request logging. Fortunately, I don't do authentication myself, otherwise I probably wouldn't have thought about this either. And I'm pretty sure that many of you wouldn't have done that either. Facebook took a lot of crap for this because it's Facebook, of course. And people were proclaiming that the engineers building this were retarded and things like that. And it's like, what's the point of that? Because GitHub had the same problem, just a bit sooner. And Twitter had the same problem. And all of these companies had that problem. And you know why it was detected? Not because of automated log monitoring and AI-based intelligence systems. No, it's because of manual effort. Because somebody looked at the log and said, like, holy crap, that's a password. Oh crap, we forgot to indicate these fields as sensitive and they should have been excluded. And I can tell you afterwards, because time is running out, but afterwards I can tell you stories of other things that I've heard that are only detected by manual analysis, because nothing goes over a human's capability of analyzing these logs. These things are not done by tools, it's done by humans figuring out, like, this doesn't really make sense, and digging deeper and finding these problems. And that brings me to the conclusion. If you want to take security seriously, you need to invest in people. Give people the time to handle security. Give them the responsibility to handle security and educate them on security as well. Thank you.